Question 1. What is the fundamental difference in the output pulses between a Q-switched laser and a mode-locked laser? While Q-switching stores energy to emit high-power nanosecond pulses, mode-locking locks the relative phases of cavity modes to generate ultra-short picosecond or femtosecond pulses. Question 2. In a classic helium-neon gas laser, what is the primary physics role of the helium atoms? Helium atoms are easily excited by electrical discharges. They then collide with neon atoms, transferring energy resonantly to excite neon to the states required for lasing. Question 3. What critical optical condition must be met in a nonlinear crystal to ensure efficient second harmonic generation? Phase matching ensures that the fundamental light and the generated second harmonic light travel at the same phase velocity, allowing constructive interference to build up output power. Question 4. What Nobel-winning laser technique stretches, amplifies, and recompresses ultra-short pulses to achieve petawatt peak power safely? Chirped pulse amplification stretches ultra-short pulses in time before amplification to prevent damage to the optical medium, then recompresses them to achieve astronomical peak powers. Question 5. What frequency tool uses equidistant, phase-locked spectral lines generated by mode-locked lasers for ultra-precise optical metrology? An optical frequency comb provides millions of equidistant, phase-locked spectral lines, acting as a highly precise ruler that links optical frequencies directly to microwave standards. Question 6. In laser Doppler cooling, why must the cooling lasers be read to tune slightly below the atom's resonant transition frequency? By red detuning the laser, only atoms moving toward the beam see the light blue shifted into resonance. This forces them to absorb photons and experience a deceleration force. Question 7. What gas discharge laser uses transient noble gas halide molecules that exist only in electronically excited states? Excimer lasers rely on reactive molecules like krypton fluoride. Because their ground state is completely unstable, the molecules instantly dissociate upon emitting high-energy ultraviolet light. Question 8. What optical spatial filter arrangement is used to scrub high-frequency spatial noise and clean a laser beam? A spatial filter focuses the laser beam through a microscopic pinhole. Since spatial noise lies off-axis, the pinhole physically blocks these aberrations, producing a clean Gaussian wavefront. Question 9. What metric defines the maximum optical energy or power density that an optical surface can handle before physical damage occurs? The laser-induced damage threshold, or LIDT, is the standardized metric that defines the maximum laser power or energy density an optical component can handle without physical breakdown. Question 10. Which laser category uses relativistic electron beams passing through periodic magnetic structures as its gain medium? Free electron lasers accelerate a beam of relativistic electrons through a magnetic undulator. This forces them to wiggle and radiate coherent light, offering unparalleled wavelength tuning.